All right, Algebra 2, here you go. This is your LFR1 last check, slope and rate of change. You can read your rubric there that you got to do. Let's go ahead and start right with the values. So find the rate of change or slope of the line containing the pair of points. Simplify any fractions. Do not convert to mixed numbers or decimals. That's in bold letters, all caps. Don't do it, okay? Remember our slope is m equals y2 minus y1 over x2 minus x1. This is like x1, y1. This is like x2, y2. Plug them in. Negative 12 minus 7 divided by 8 minus 4. You get negative 19 over 4. Do not simplify because it can't be. Don't put it as a mixed number. Don't put it as a decimal. That's it. That's all you're trying to do right there. Again, x1, y1, x2, y2. M equals negative 1 minus negative 2 divided by 3 minus negative 6. Negative 1 plus 2 is 1. 3 plus a positive 6 is 9. And you're done. And you're done. Right here, part C. Don't freak out because there's fractions. Put it in the slope formula and see what happens. M equals 8 thirds minus 4 fifteenths divided by 2 ninths minus 2 ninths. There's your key, right? This is going to be not 0 on top. On the bottom, this is 0. 2 ninths minus 2 ninths is 0. So what happens when you divide by 0, when 0 is in the denominator, not 0 is not in the numerator, when you're dividing by 0, that's called undefined. This is a vertical line. This is undefined. If you're not sure, sketch yourself a little graph, okay? And then you have to be to scale, right? 2 ninths, 4 fifteenths, and 2 ninths, 8 thirds. It's a vertical line, okay? Vertical line. The x coordinates are the same. Part D. Okay, let's look at this. I didn't even have, the points are right here. These all go by 1. You got to make sure of some stuff, right? This is going downhill. This has to be a negative slope. If we do this, you could make this. This is like negative 1, negative 1. This is 1, 2, 3, 4. 1, 2, 3. 4, negative 3. 4, negative 3. So you could use the slope formula, or you could remember that it's rise over run. I'm going down 2, and running 1, 2, 3, 4, 5. And running 5. There you go. You don't even have to do the slope formula. Just count it out. Let's look at the next one. I got these 2 points, but you can also notice it goes through these in between, and that's okay. We'll take a look at these here. This is like negative 1, 2, 3, 4, negative 4, comma 1, 2, 3, negative 4. And this is 0, comma 1, 2, 3, 4. This is 0, comma 4. So this would be rising how many? 8. Running how many? 4. Rising 8. Running 4. Simplifies to 2, or 2 over 1, right? Rise 2, run 1. Hey, rise 2, run 1. Rise 2, run 1. Nailed it. Okay, here we go. A few years ago, the Brayman family took a trip to the Porcupine Mountains in the UP. Took quite some time to arrive, but a good time was had. The table shows the distance from home to the destination during the day. Find the rate of change for each time interval using the correct units. Okay. X and Y. If I travel 134 miles in 2 hours, what does that give me? That's like 67, or here we go, we can think of it like this, 134 in two hours. 134 over 2. This would give me 67 over 1, or 67 miles per hour, right? That is what we're doing. You could even abbreviate if you wanted to. Miles, hour. Hour 2 to hour 3, that's a difference of 53. 53 miles in 1 hour, or just 53. Hour 3 to hour 7, what is that a difference of? Let's go ahead and take a look. All right, so we've taken a look, hour 3 to hour 7. The change in distance is 236 miles, but that happens over a period of 4 hours. If we simplify that, this ends up being a nice round 59 miles in 1 hour. Hour 7 to hour 9, the difference there is 128 miles. And that takes place over 2 hours, giving us a rate of change of 64 miles per hour. So it's not just about distance traveled. You have to do the rate of change in y over change in x. Which interval had the greatest rate of change? Well, let's see. It looks like right there, hour 0 to hour 2. To hour 2. Why? Biggest slope. Biggest change in distance per change in time. Change, that's my delta, little triangle. Biggest change in distance per change in time. Not about which interval was the longest or the biggest miles. That change was between 3 and 7. That was not. That was the second slowest of those. Interpret the context of the rate of change between hour 2 and hour 3. In other words, what does the slope represent in real life terms? Hour 2 to hour 3, it was 53 miles per hour. So you could say it went 53 miles in 1 hour, or in 1 hour went 53 miles. Or 53 miles traveled in 1 hour. Okay, that's your 1 through 3 level work. Let's take a look at those 4 level questions. Find the value of r so that the line through the points has the given slope. The 2 points, 2, 3, and negative 2r. Treat this like x1, y1, and x2, y2. So my slope would be m equals r minus 3 divided by negative 2 minus 2. Let's simplify what we got. R minus 3 divided by negative 4. Well, I know at some points this has to equal positive 5/4. What can I do to get common denominators here? Because I want to compare these two fractions. Well, what I could do is this. I can multiply this side by negative 1 on top and bottom, because I'm just multiplying. That's just multiplying by 1. And this would give me r minus 3 divided by negative 4 is negative 5 divided by negative 4. Now I can compare. Since the denominators are the same, that means the top has to be the same. In other words, r minus 3 has to equal negative 5. And if I add 3 to both sides, r equals negative 2. Check your work. Plug it back in here. Negative 2 minus 3 is negative 5. Negative 5 divided by negative 4 is a positive 5/4. That works out. Checks out. Cricket the Pony was given the x-intercept and the slope of the line. With this information, would he be able to know if the y-intercept is positive or negative? Justify your answer using complete sentences. It's a really good question. The discussion that we had, we said yes. Reason being, I also used some diagrams too, right? So if I know my x-intercept's here and I know I've got a positive slope, I know that I would have a positive y-intercept. If I had a negative, if this was a negative slope from here, I know I'd have a negative y-intercept. Even if it's at the origin, if your x-intercept's at the origin, you don't even need to know what the slope is because your y-intercept would also be at the origin. So a lot of good things. I also heard some stuff about horizontal lines. So if you know the slope and you know that you've got an x-intercept of 0, well, or whatever it is, and it's a horizontal line, that could be, you would know exactly where it was every time. So using any of those three statements, or those, I mean, not three statements, any of the statements we talked about, or using your own justification, that's what we're looking for. There we go. Take care. Have a great one.